Okay, so we're going to start using calculus to help us sketch these curves. So we're still going to deal with the basic points that we were dealing with, mainly zeros, y-intercepts, uh, those things that we did with polynomials. We're going to add in dealing with these critical points. Okay, so where the derivative is equal to 0. Okay, we want to make sure that we are dealing with those. We want to also know where the derivatives don't exist because those are points of interest. For example, asymptotes, holes, discontinuity points, kinks in the graph. And so when we graph these, we're going to look for these points, and these are points of interest. The main ones we're going to look at for today are the vertices. These vertices are what we call turning points, and they're based on the first derivative test. So we're going to look for horizontal tangents. We're also going to use the derivative to find increasing, decreasing regions. And we're going to add in also that for some of these, we're going to look for inflection points where the curve changes concavity. Okay, so where it goes from concave down to concave up. Okay, so the example is given here. Okay, so if we take a look at that graph, okay, you can see that there is a concave down here. Okay, so that's concave down. And when we change to concave up, okay, here, that point is called an inflection point, and we're going to find that where the second derivative is equal to 0. So we're going to show the increasing and decreasing regions using a slope chart. Okay, so basically we want to know where the graph is positive and negative, and the transition between positive and negative is when the slope is equal to 0. Okay, so this is what the key then is we're going to look for where the slope is equal to 0.